Hi, in this video, we're going to talk about ways to install R packages onto your machine or your environment. All right, so why am I doing this video? All right, so right now, I work in the cloud. All my notebooks are in the cloud. And when I spin up a notebook, I get it into the system. And any package that I want to use that's not already in the system as it's already been built for me, I have to install packages. Now, next day, I need to go and reinstall those packages again. Or if I restart the kernel, or if I get away from my machine and come back and I've lost the connection, I have to reinstall those packages. And so this is eating into my time at work. I take advantage of it, go take a break, get a sandwich. I'm good with that. But, I'd rather just not have this issue. So what I'm doing here is I'm going to explore different methods to install packages so that way I know what is likely to take less time than others so I can put less time into the installation. And so if you are working in a cloud environment such as AWS, doing Python notebooks in AWS, or if you're doing notebooks in Databricks, or a similar structure, similar situation, uh, you're going to have to deal with this problem every time you set things up. All right, so uh, there's a couple things that we can do to speed things up. First and foremost, do not install or update packages unless you're actually going to use them. That's just by far the easiest way to not make this an issue. Just don't install what you don't use. I'm really big on that personally. We can also cache install packages in a persistent library. Now, I'm not going to show how to do that here because that's going to be specific to your machine, your environment, how you're dealing with it. I really can't help you with that without being at your computer. But the next ones I can actually help you with and give examples. So first and foremost, don't install packages that I don't need to use. All right. So let's say that a package has a dependency, but I'm not going to use a function that actually invokes that dependency. Then I don't need that dependency on my machine. So potentially I could trim that out. So how R has it set up is that they'll have a package. That package depends on another package for certain aspects. And if I'm not using any of those aspects, I'm not going to install that secondary indirect package onto my machine. Now, let's say that I do need that other aspect, but I don't need other dependencies. I can go and install only the packages that have a dependency that I'm going to be invoking in my project. And so this can help save me some time. So an example of this that I encounter is that with the Janitor package, I like the way that it cleans up column names to make all my column names syntactically correct, and they're easier to read. And I just, just a subjective decision, I prefer those. Well, they use a snake case in that. They actually use a snake case in the cleaning up of column names as the way I like it. I prefer snake case over camel case or other variations, um, leopard case or anything like that. So I need snake case in there. So I'll go ahead and install snake case with dependencies equals false, and then I'll install the janitor package, and then boom, I can run it. I don't have a whole bunch of additional dependent packages being brought in. Now, another thing that we can do is we can set quiet equals true to help reduce the output. This really isn't going to be that big of a savings, but we're trying to speed things up. We can also set verbose equal to false, but this is going to be redundant when quiet equals true because the part that would be verbose is not being printed, so it's not much of an issue. We can also use the type of binary whenever possible to avoid a compilation. This will be specific to Windows, by the way. And then we can also run the parallel package mclapply to do parallelized installation of multiple packages. Okay, and so now let's get into methods to actually install packages. So what I'm going to do, I'm going to go through and I'm going to install the survey package a whole bunch of times. All right, every time that I install a survey package, I'm also going to remove it first, so that way I can just see what happens as I go through this. So I'll remove the survey package and then go install it back on there, and I'll be able to benchmark the results, see how long it takes for my code to run, and for each individual function I use, I'll compare at the end to see which ones are the fastest. By the way, my results contradict what I've read on the internet. So stay tuned. All right, so I'm going to kick it off with the most basic way possible, install.packages. Base our way to go. All right, so if I have survey package on there, I'm going to go ahead and remove it. Now I'm going to go through and, so on this list, I'm going to save the system time. So you notice I call it list system time. That's how I like to name my objects. The type of object and the description of what I've got. And I've got system time to evaluate how long it's going to take. Here's the expression that's being measured for time. And I'm running install.packages. I'm installing the survey package. Now you'll notice I've gone through and tried to reduce the amount of time that's going to take. I've got dependencies equals false. Now, let's say that I put that to true. Then true is going to automatically manually install all dependencies automatically for you. Now, if I put it to NA, with NA, it will only install the dependencies I actually need. And so if false isn't appropriate, NA will go ahead and install dependencies, but it's not going to give us ones that we don't actually need. So it's a faster choice. If I can, I want false. Then quiet equals true. Not a big savings, but you know what? I'm trying to trim down time, so let's go ahead and do it. Verbose, I've got this as redundant because quiet already takes care of that, but just so that you can see that aspect. And I'm going to go ahead and specify the repo. The reason why I do this is because other functions that I'm going to show in a moment, we have to specify the repo to install the CRAN packages. So I'm just going to do that here just to be consistent with the other ones. All right, so now I've got my results. Okay, so let's keep on going through. Now the pack package, according to the internet and according to my Copilot research that I did using GenAI, the pack package is supposed to be faster. All right, well, we'll find out. All right, so first thing I'm going to do, I'm going to remove the package because I want a fresh installation and check the time. So once again, I'm going to install the survey package, put dependencies equals false, upgrade. Now this is specific to the package, upgrade equals false, ask equals false. There is an interactive aspect to this. Anything interactive probably is not going to run in a cloud computing environment. Probably, if I want to run something interactive, like with a sub window opening up, I probably want to have it on an actual machine. All right. And so we can see the results. We have some more stuff going on. 13.7 seconds just right off the bat. Look, that's longer than all that put together. Huh. I'm surprising. Considering the internet said it's the best. All right, so here, look at all that. Now we can also use the BIOC manager function to do this. And so when we do this, I have to specify the repository. So this function is not specific, it's not really intended for installing CRAN packages, but it gives us the option of it. And since it gives us the option, I'm going to go ahead and show. Now, you'll notice that also I've gone through and I've tried to make everything as quick as possible. No dependencies, make it quiet. Don't give me a lot of text if you're going to give me any. And let's see what happens. All right, so it's somewhere between the two that we've looked at so far. Now here is remotes. Typically, professionally, I use remotes and dev tools when I want to install a former version of a package, but I can still use it to install the current version of a package. So this is a tool in our tool belt if other techniques don't work out for us. All right, and it's something that's very nice, and DevTools reflects this also. They're very consistent with each other. I'm going to use install CRAN. If I want something from the CRAN repository, then I want to use install CRAN. That's the way to go. And you'll notice that a lot of the parameters match install.packages throughout. And that's not a coincidence. The authors of these packages intentionally either allowed parameters to be, invoking like install.packages, or they, copied and pasted and mimicked what they saw in install.packages. And so, I'm, making things a little bit faster. We can see our result. All right, that's not too shabby. All right, now let's do DevTools, and you'll notice it's exactly the same function name in DevTools as remotes. All right, and we get a lot more. So DevTools likes the RTools package, so I would avoid using DevTools, honestly, just because I don't want that additional aspect, and I don't like you know packages messing with my system. So I would shy away from DevTools for most things. And so here I've got my result. All right, not the best, not the worst. Now, Groundhog, what Groundhog does is that I can specify the date of the version of the package I want. So let's say I was working on something, I didn't write the package version down, but I knew that I took the most up-to-date version from March 1st, something like that. Okay, so what I can do, I can say, hey, take the date from March 1st and give me that version of the package. Boom, it'll take care of it for me. It'll figure it out. Now, when it does this, something of the groundhog function is that what this does when I call library, it'll check to see, do I have the package installed? If I don't, it will automatically install it for us. So it's a nice version of library in that I don't have to make sure that my package is installed. That way, it's a little bit easier, hands off. But that, there's a little bit of extra step going on. I recommend that you avoid using the library function and use double colon notation to call functions. Now, the exceptions to that is when I know I'm going to be using a wide range of features of a package, and I know I'm not going to have conflicting names of functions within the packages that I'm using. All right, so let's run through this. I have to specify a date. The groundhog package does not like using today's date, so I just rolled it back 3 days. Boom, I've got that. And you notice that there really isn't a whole lot for me to put down. There weren't a whole lot of options with this one either. And you'll notice it takes much longer for this, but it's set up to do more for us. So, advantages and disadvantages. Now, for my purpose, here and now, I'm only concerned about speed. Speed is all I want. Also, this function automatically loads a package into my workspace, which I don't like. So you know what? I probably wouldn't use this one, but I'm glad that it exists because this is a good tool to have in your tool belt. All right, so now let's compare methods. Drum roll, please. Let's see how they compare. Boom, let's look at this. All right, so I've sorted them by their average time across the different types. And I sorted the type of time, and I sort by the average amount, and I sorted the installation function by the average amount. And so we can see off of this, install packages was the fastest one, then remotes, then DevTools, then BIOC Manager, then Pack. That is really surprising because over and over and over, I read that Pack was faster. But you know what? This is what I'm seeing at work also when I install a package on Pack. Like, wait, why is it taking so long? And then Groundhog took a long time, but we know why. That's right. Now, as I went through and tried this multiple times to, check it, what's going on, install packages and remotes switched order. in this, a couple of different times. And so install.packages is a good choice if I want speed. Remote is also a good choice if I want speed when I am not installing dependencies. All right. So that's all I've really got for you. I hope you really enjoy this video. Um, if you have a data science need, data science question, let me know. I'd love to help you out. And remember, life is short. Do math.